In this tutorial, we are going to model this beam structure subjected to a complex distributed load and also supported by a spring. Note the Young's modulus is 123 gigapascals, and we know the second moment of area and the spring constant and the load intensity of distributed load. And the length, half length of the beam is 1 meter. So the total length is 2 meters. Now in ANSYS Workbench, we are going to create a static structural. First, we are going to create a material. This material will have a Young's modulus 123 gigapascals and the Poisson's ratio 0.3. And we can actually delete structural steel from here. Next step is geometry. We already have the geometry file, so we're going to import geometry. So from the folder, this AGDB, ANSYS geometry database file. After that, we update the model. Double-click to open ANSYS Mechanical. First, look at geometry and align body with a rectangular cross-section. And now the model type will be beam, and the material should be this material we created. And for mesh, we can define element size here. So we are going to use 8 elements. So each element will be 0.25. So note the unit now is millimeters. So we could change to meters for now. So 0.25 in meters. And generate mesh. So now there are 8 elements. Now we could apply boundary conditions. And before we do that, we need to add that spring to this beam structure. So now, since we don't have any point to attach the spring, we are going to need to use the node. to attach the spring. And it would be convenient if we create a named selection. So insert a named selection. We have two methods, like a geometry selection or worksheet. We are going to use worksheet. So in this worksheet, at the moment is blank. So we need to right click to add. So add entity type will be node, mesh node, and the criterion is the location x. So x coordinate to be at the midpoint will be 1 meter. So equal unit meter value 1. And after this, generate. So now we have a named selection for that particular node. And in order to attach a spring, we need to insert connections. And in connections, we need to add a spring, which is the body to ground connection. So spring stiffness or spring constant will be 2000 kilonewtons per meter. So 2000 Newton per meter. And reference will be defined by global coordinate system. So let's say at the midpoint, x coordinate is 1, and y coordinate will be about a quarter meter downwards. And for mobile, instead of a geometry selection, we change to named selection, which is so we have to do a direct attachment. Selection. So that selection is the named selections that we created. So now we have the spring being defined. And now we can apply boundary conditions and right click to insert a fixed support to this point on the left. And so then we apply distributed load. For distributed load, we have to use commands to define the distributed load. So what we do is we insert commands and paste the commands here. So now there is a do loop from 1 to 2. And first, we select elements based on the centroid location. And from point 5 and to 1. And this is to apply linearly increasing distributed load. So we have two numbers for this SF beam surface force on the beam, and this is the pressure. So we have two different numbers to define like a linearly varying distributed load. And these two lines are for defining that constant distributed load. So we only need to use one number for this purpose. So this will be from 1 to 1.5 meters. After that, we can insert the results that we are going to look at. So first, directional deformation. Now we are going to look at Y deformation. And then we can insert, go to probe, force reaction due to fixed support. And again, moment reaction due to fixed support. And insert beam result, bending moment, and the beam result, shear force. And in order to get a stress, we need to change beam section results from no to yes. And we can insert stress. In order to see the stress, we need to use user-defined result. And the expression is Sx. Also, for rotations, we also need to use user-defined result, that is Rz. So after this, we can solve. So we have this is deflection, and we can change the scale. And this is the bending moment and the shear force. So that we can change the view. And then this is a force reaction and a moment reaction. And then this is a rotation and stress. So for user-defined result, we need to note the unit when we create the user-defined result. If we use meters, now if we change the unit to millimeters, we can see that for user-defined result, their unit won't change, and so this will be still in the Pascals. And but now the other like this one, directional deformation will be changed to millimeters. And likewise for this one will be in radians. And so moment will be in Newton millimeter, and force in newtons. So here we used 8 elements. Of course, you can change the number of elements, but need to note that if the element numbers uh, have changed, so you also need to modify all the command lines. That would be all for this tutorial. Thank you.